Okay, today I would like you to open up your books to page 462. We're going to continue with Chapter 6, Lesson 4. We're focusing today on problem solving. Now, in this particular problem, it says while in normal flight, a bald eagle flies an average speed of 30 miles per hour. So it says that we need to write an equation and make a table to show the relationship between the total distance that a bald eagle can travel in h hours. Okay, so let's fill the table in first. And I'm looking down here. Let's figure out what, I don't know, 0 hours would be. Then how about 2 hours, and how about 4 hours? Okay, so again, the number of hours is going to be the independent variable. So I could have chosen any number. In fact, I could even extend this out and say 9. Okay, so let's just put 9 there as well. So in 1 hour, the bald eagle is going to go 30 miles per hour. But if you have 0 hours, the distance they're going to go is 0. So 2 hours would be the same as 2 times 30, and so that's going to be 60. And then 4 hours should be the same as 4 hours times 30. And 4 times 3 is what number? That's correct. So that's going to be 12 with a 0, because that's not just 3, it's 30. So that's going to be 120. And then we have 9 hours times 30. And what is 9 times 3? Exactly, 27. So this is going to be 270. All right, so put a little line there so we can make that clear. Now it says to write the equation. So basically, the distance changed depending on which numbers we chose up here. So we're going to use the variable d for the dependent variable distance, and that's going to be equal to 30 times whatever number of hours we choose to figure out. So this is going to be our equation. Now we need to graph this. So basically, this is going to be the x value because it's the independent variable, and this is going to be the y value. So here's the x-axis, and that's going to be the time, the number of hours. So if we have 0 hours, it's going to be 0 distance. So that's going to be the first point that I graph. Then I have 2 hours. I come over to 2. I'm going to go up to the number 60, and I'll put up my point here. Then I have 4. I go over to 4 hours, and I go up to, actually, it's not even on the graph. It's way up here. So, you know what? I'm going to go back, and I'm going to figure out, I'm going to something a little bit more simple here. So we have 1 hour is going to be 30. And let's do 3 hours. 3 times 30 is going to be 90. Okay, I was a little too ambitious with my graph over here. So 1 hour is going to be 30. So I go to 1, I go up to 30. And then 3 hours is going to be 90. And so if I connect these dots, I can see the linear relationship, and it goes through the origin. And if we've noticed that anytime in multiplication is involved, it's always going through the origin of 0, 0. That's important for us to remember as we're doing our next lesson later this week. So we graph the ordered pairs, we analyze the graph. So to analyze this, what sort of shape does it make? Linear. Also, it increases by, that's supposed to be increases by 30 every time is another thing that's kind of important for us to note. And the fact that it also goes through 0, 0 is an important thing for us to note. So in the end, we have a linear graph that goes through the origin, and for every hour that we go, we are going to increase our distance by 30 miles. Okay, so now you should be on page 465. We're going to do number 8 together. It is a multi-step word problem. First thing we're going to do is going to read it. Brian's baseball team is hosting a tournament to help raise money to buy new uniforms. Each team pays $100 to compete, but some of the money will be used to pay for the uniforms. Use the table to help you find the amount of money raised for uniforms if six teams compete. Now, so we analyze the problem. First thing we have to do is just read it, and then we're going to go back and circle information that we know and underline what we're being asked for. I like to read the problem first, then I go back and I look just at the end, just at the question. And it says, use the table to help you find the amount of money. So I'm going to underline the amount of money. And the other important thing is uniforms if 6 teams compete. So we're looking for money for uniforms and 6 teams. How am I going to figure this out? Well, I'm going to circle the information we know, and they've told us to use the table, so this is the information that we know. We need to figure out the pattern in the table. It says the number of teams competing, 1 team, the money for uniforms, $50, 2 teams, $100, 3 teams. Okay, so we're looking for a pattern over here. So we're going to determine the rule of the table first, and then we can extend this table since the number of teams is the independent value. I can choose to extend the table and put whatever number that I want here. So ultimately, I'm going to put 6 here because that's what I want to figure out for my answer, 6 teams. So what do I do to the number 1 to make it the number 50? One thing I can do is add 49. Let's see if that rule actually works for every relationship here. Is 2 plus 49 going to equal 100? Go ahead and answer that for me. All right, the answer is no. So it's not going to be an addition relationship. So what is something else I can do to the number 1 to get to the number 50? Go ahead and answer that for me, please. All right, you're correct. The answer is to multiply. So 1 times 50 is going to equal 50. Does 2 times 50 equal 100? Yes or no? It does. So that means I can go ahead and write my equation. So the number of teams and the amount of money. So the amount of money, I'm going to go ahead and I'm going to use M as the variable for that. The money depends on the number of teams, and I'm going to put T here as that variable. But in order to figure out how much money each team, the rule was multiplying by 50. So this is my equation. The money is going to be equal to $50 times the number of teams, okay? And I'll go ahead and put that in parentheses to make it a little bit more obvious. That's multiplication, okay. So now that we have determined the rule and we've written the equation, all we have to do is finish this table by using the same rule and equation. So down here where it says solve, it says each dependent quantity is blank times the independent quantity. And we've discovered that is 50. And so the rule is, they chose to use the letter Y, that's fine, so we'll use X down here. So that's going to be 50 times X. But again, the variables don't matter, so money is equal to 50 times teams, and Y is equal to 50 times X. This is the same thing. So the amount of money for 6 teams is going to be 50 times, this number is going to be 6. And how much would that be? What is 50 times 6? Answer that for me, please. All right, very good. That answer is 300. So up here in the table, that's going to be 300. Now, how do I know that I have the right answer? So up here, I said 300 was the answer. That means that C is going to be the correct answer. How do I know that's right? Well, I can go back and look over here. So if my rule is 50 times T, 3 times 50 is 150. The rule is working for every single relationship, so I know that I have this correct.